Step 4 of our lab asks us to use the center of mass that we found in part 1 and determine the mass of our meter stick using only one additional known mass. So we've selected the 100-gram mass, and we're going to try to put this entire meter stick into equilibrium. You can see if we have just one mass on the left-hand side, the whole thing rotates counterclockwise. So it's necessary for us to move the pivot point, move the fulcrum, just like seesawing with a person who's not the same weight. We still want to try to achieve equilibrium by getting the torque on the left side equal to the torque on the right side. So now we remember that the entire mass of the meter stick was located at the center of mass, which for us was at the 50.8 mark. So now we have to move. You can see we have the 100-gram mass here at the 25, and that creates a force, and that force times this R, which is measured from where the weight is to the fulcrum. So now you can see that our fulcrum is at about 36.2 or 3. You can decide that in the film. And so that gives us torque on the left side. Well, that has to equal the torque on the right. So where's the force on the right? Well, the force on the right is located at the center of mass in the meter stick. So you have to find the distance from the center of mass that we found in step 1 to the radius. So, or to the fulcrum, which gives us R. So simply this force times this R has to equal this force times this R, and you should be able to calculate the mass of the meter stick.